In today's comprehensive exploration, I embark on an investigation of the law of resonance, a subtle yet fundamentally impactful principle that governs the interaction of frequencies in multiple contexts of our universe. My exploration is grounded on rigorous scientific principles and historical examinations that have evolved over centuries, now intertwined with advanced theories in modern physics and neuroscience. The concept that like frequencies interact is not merely an esoteric or metaphysical idea, but stands as a critical mechanism in understanding energy dynamics in fields ranging from acoustics to quantum resonance. I examine how environmental variables, measurable in sound, electromagnetic spectra, and even bioelectrical oscillations, can be considered as manifestations of the resonance phenomenon, influencing both macroscopic and microscopic systems with predictability and precision. This analysis conveys a narrative that merges technical examination with historical context. In tracing the evolution of resonance from its earliest conceptualizations in alchemy and Hermetic tradition to its adoption in contemporary scientific inquiry, I develop an understanding that resonates well with the informed observer. The narrative is underpinned by detailed mechanisms, including the synchronizing of brain waves and potential applications in sound healing modalities. Through my narrative, I invite the audience to join me on a journey, an unfolding of sophisticated ideas backed by empirical evidence, mathematical modeling, and historical insights. The focus remains consistently on precision, clarity, and depth as I detail the complex interactions that define the law of resonance and its multifaceted impacts on both natural and engineered systems. In synthesizing historical insight with contemporary scientific modeling, I strive to provide a layered understanding that challenges preconceived notions and offers robust analytical frameworks for further exploration. This journey sets the foundation for the technical dissection to follow with utmost rigor. Delving deeper into the law of resonance, I now provide a detailed exposition of its definition and underlying mechanisms from both a classical and modern perspective. At its core, the law posits that energy frequencies, when aligned in compatibility, engage in harmonic induction, where constructive interference leads to amplified vibrational effects. Conversely, when frequencies are misaligned or mismatched, destructive interference arises, diminishing energy transfer or yielding chaotic, nonlinear dynamics. These fundamental interactions are analogous to interference patterns observed in wave physics and are mathematically described using Fourier analysis and complex amplitude modeling. Advanced theoretical frameworks, such as quantum field theory and nonlinear dynamics, further elucidate how resonant phenomena manifest across disparate systems. I integrate precise mathematical formulations to support these observations. For instance, when two sinusoidal waves of equal frequency and phase interact, their superposition can be mathematically represented as twice the amplitude of a single wave, thereby illustrating amplification in a quantifiable manner. In comparison, waves with opposing phases result in cancellation. Such theoretical descriptions find practical expression in resonant cavity designs in photonics and the operational principles of nuclear magnetic resonance (NMR) instruments in medical imaging. These rich technical insights underscore that resonance is not limited to abstract theory, but is observably verifiable through empirical studies and controlled experiments. The analytical methodologies employed, including spectral decomposition and harmonic oscillation techniques, serve as indispensable tools in both academic research and industrial applications. This blend of mathematical rigor with experimental validation positions resonance as a unifying concept that bridges the gap between classical physics and modern engineering. By integrating rigorous mathematical derivations with advanced laboratory experiments, I underscore the applicability of resonance theory in designing future technologies that could revolutionize communications, sensors, and beyond. This blend of science and art exemplifies mastery. Tracing the historical evolution of resonance theory reveals a fascinating interplay between mystical traditions and the rigorous demands of modern scientific inquiry. In ancient alchemy, practitioners explored the properties of materials by engaging with the subtle energies presumed to resonate from each element. Alchemists meticulously experimented with base metals and natural compounds, theorizing that specific substances possessed intrinsic vibrational qualities capable of influencing other materials and energies. Their rudimentary observations, though steeped in symbolism and allegory, laid an early intellectual foundation for the concept of resonance. These alchemical insights suggested that the vibrational signature of a substance could be activated under controlled conditions, a notion metaphorically akin to modern resonance phenomena. Moving forward to Hermetic teachings, the maxim, as above, so below, encapsulated the belief that resonance operated across both the microcosm and macrocosm. This philosophical dictum implied that cosmic principles governing the movements of celestial bodies were mirrored in the minute vibrations of earthly matter. Such holistic views promoted a unity of existence, where disparate levels of reality were integrated by a fundamental principle of vibration. The transition into modern scientific paradigms brought resonance into sharper focus with the advent of advanced instrumentation and quantitative analysis. Experimental breakthroughs, such as the discovery of electromagnetic resonance and the validation of acoustic resonance in controlled environments, confirmed many of the early hypotheses. Detailed studies using precise instrumentation, such as oscilloscopes and spectral analyzers, quantified the phenomena that alchemists and Hermetic philosophers only intuited. For example, research in brainwave entrainment demonstrates that neuronal oscillations synchronize under the influence of rhythmic external stimuli, aligning closely with resonance theory. Furthermore, modern physics has formalized the understanding of resonance through mathematical models and simulations. The concept of sympathetic vibrations in mechanical systems and resonance frequency in electronic circuits serve as exemplars of how resonance principles now underpin device engineering and signal processing. Historical and contemporary perspectives, when considered in unison, articulate a continuum of discovery, from the metaphorical and speculative to the rigorous and computational. Each era has contributed critical insights, collectively advancing our understanding of resonance as an indispensable principle in both science and technology. In sum, the evolution from mystical practices to precise scientific inquiry encapsulates the transformative journey of resonance understanding, reinforcing its enduring and evolving significance beyond measure. Transitioning from theory and history to tangible impact, I now examine practical applications of resonance across various domains. In the realm of social interaction, resonance manifests in subtle yet measurable ways. For instance, the tonal modulation and rhythmic patterns inherent in human speech can be analyzed using spectral methods, revealing frequencies that either enhance or dampen interpersonal connections. When two individuals engage in conversation, their vocal vibrations may synchronize, a phenomenon supported by recent neurophysiological studies, thereby facilitating a more efficient exchange of ideas and emotions. This synchronization is not incidental. It is underpinned by complex bioacoustic processes that align with resonance theory. Environmental resonance is yet another facet with significant implications for daily life. In controlled experiments, researchers have demonstrated that ambient factors such as light frequencies, background soundscapes, and even olfactory cues exert measurable influences on human cognitive and emotional states. For example, exposure to certain types of music with specific harmonic structures has been correlated with improved mood and increased productivity in workspaces. Likewise, architectural acoustics utilize resonance to optimize sound distribution in concert halls and public forums, ensuring that auditory experiences are not only heard but felt at a profound level. Advanced sensor technologies now allow for the real-time monitoring and adjustment of these environmental factors, creating dynamic spaces that actively promote well-being and efficiency. On a personal level, resonance directly impacts individual states of being. Empirical research in neuropsychology has shown that regular engagement in practices that harness resonant frequencies, such as mindful breathing, meditation accompanied by sound therapy, and deliberate vocalization, results in measurable changes in brainwave patterns and autonomic regulation. Quantitative studies employing electroencephalography, EEG, have documented enhanced alpha and theta wave activity during these practices, correlating with heightened states of calm and focused attention. Such findings not only validate long-standing anecdotal evidence, but also provide a framework for developing novel therapeutic interventions. Furthermore, I explore the integration of resonance principles in cutting-edge technology. Engineers incorporate resonance arguments when designing filters and oscillators in communications and computing systems. The predictability of resonant frequencies enables the fine-tuning of circuits and improves signal clarity. By applying mathematical models grounded in Fourier analysis and harmonic balance theory, the optimization of resonance effects in devices is achieved, markedly advancing modern electronics and sensor design. Clearly, the practical implications of resonance span a wide spectrum, from enhancing human interactions and environmental conditions to optimizing personal well-being and fostering technological innovation, a robust testament to its pervasive influence. By meticulously applying resonance theory, experts across disciplines refine practices and develop innovative solutions that optimize system performance, demonstrating that the confluence of empirical research and theoretical precision in resonance is essential for advancing both scientific inquiry and practical technological applications with rigor unmatched. I now introduce a series of guided exercises designed to enable a deeper experiential understanding of resonance phenomena in controlled settings. In the first exercise, practitioners are encouraged to engage in sound resonance practice by vocalizing a sustained vowel or reciting a carefully chosen mantra. During this practice, individuals may observe the propagation of vibrational energy throughout their physiological structure, as measured by subtle tactile sensations and, where available, biometric devices. This exercise is rooted in precise acoustic principles, wherein the emitted sound serves as a stimulus that encourages the body's natural tendency toward entrainment with specific vibrational frequencies. The process of entrainment, well documented in theoretical models and supported by empirical research, provides an opportunity for participants to witness firsthand the synchronization of internal bodily oscillations with external acoustic stimuli. By concentrating on the resonance of their voice, individuals may detect shifts in bodily rhythms, noting an alignment with the sound's frequency that can be observed in muscle relaxation and respiratory patterns. For the expert, this controlled experiment offers more than mere subjective experience. It is a practical illustration of resonant energy transfer that complements quantitative measurements. In a complementary exercise, practitioners are advised to maintain a detailed journal wherein they document instances throughout the day when their interactions and surroundings either elevate or deplete their energy levels. By systematically recording these instances, patterns of resonant compatibility or interference can be identified. Data from such observational studies can be subsequently analyzed using statistical methods and spectral analysis techniques to reveal correlations between environmental factors and personal vibrational states. This methodical approach not only reinforces the theoretical constructs of resonance, but also empowers professionals to refine their practical application strategies in real-world scenarios. Through these educational exercises, individuals gain enhanced insight into the dynamic interplay of frequencies, effectively translating theoretical knowledge into empirical practice. By rigorously engaging with these exercises, experts can calibrate their internal resonance, contrast the results with established models, and contribute valuable data to the evolving quantitative framework of vibrational analysis. This practice solidifies the empirical link between abstract theory and measurable experience, bridging academia and application. I now transition to an in-depth analysis of how an expert-level understanding of resonance can catalyze personal transformation and optimize systemic coherence. The interplay of resonant frequencies within the human body is not only a subject of theoretical inquiry, but also a practical pathway for biooptimization. By leveraging quantitative measurement techniques such as high-resolution EEG and biofeedback instrumentation, practitioners can precisely chart the variations in neural oscillatory patterns as they engage in resonance practices. This convergence of empirical data with personal introspection offers a unique intersection where science meets subjective experience. Historical perspectives, enriched by both mysticism and early scientific thought, have often alluded to the transformative power of resonant alignment. Contemporary studies corroborate these notions, demonstrating that targeted practices, ranging from rhythmic breathing protocols to controlled sound therapies, induce statistically significant enhancements in mental clarity, stress reduction, and overall homeostatic balance. Computational models reveal that when neural networks synchronize with external stimuli, the resulting phase coherence enhances cognitive processing efficiency and emotional regulation. Such data-driven insights underscore a critical validation of resonance as a potent tool in self-optimization. Furthermore, modern therapeutic modalities increasingly incorporate resonant techniques within their protocol. Advanced practitioners utilize spectral analysis to fine-tune therapy parameters, achieving personalized interventions that maximize energetic coupling between mind and body. This intricate process, underpinned by rigorous statistical analysis and nonlinear dynamics, allows for the refinement of habits and behaviors that ultimately foster a sustained state of personal equilibrium. The confluence of neuroplasticity research and resonance practice offers promising avenues for mitigating the effects of stress-related disorders and enhancing cognitive resilience. In synthesizing these diverse threads, I present an integrated model that contends that optimal personal transformation arises when one adopts a disciplined regimen rooted in the scientific principles of resonance. This model is exemplified in case studies where longitudinal monitoring of brainwave patterns, coupled with systematic resonance exercises, has led to measurable improvements in both psychological well-being and physical health. The narrative presented here, rich in quantitative analysis and empirical validation, challenges traditional paradigms and invites experts to embrace a holistic, data-driven approach to both personal and professional development. By continuously integrating advanced resonant practices into daily routines and professional methodologies, individuals and experts can drive measurable improvements in creative problem-solving, strategic decision-making, and systemic resilience, ultimately setting a new benchmark in the pursuit of optimal human performance. This progressive integration of resonance not only refines individual capacity, but transforms organizational dynamics. In conclusion, the exploration of the law of resonance reveals an integrated framework where deep theoretical insights merge with practical empirical evidence to explain complex energy interactions. Through rigorous analysis of vibrational frequencies, supported by both historical perspectives and modern scientific validation, the narrative demonstrates that resonance is a measurable, transformative phenomenon with far-reaching applications. The discussion has dissected mathematical models, spectral analysis techniques, and quantitative methodologies that not only confirm the validity of resonance theory, but also open new avenues for innovation in technology and personal optimization. The journey has detailed how resonant interactions underpin phenomena ranging from biological processes to advanced engineering systems. It illustrates that resonance, through its capacity to enhance or inhibit energy transfer, exerts a decisive influence over both natural and human-made environments. By systematically applying these principles in contexts such as acoustics, neurophysiology, and device engineering, experts are afforded the opportunity to refine their practices and develop strategies that produce consistent, predictable outcomes. This synthesis of historical knowledge and contemporary research challenges traditional boundaries, inviting continuous exploration and empirical testing. Looking forward, professionals and researchers are encouraged to integrate resonance principles into their technical toolkits, thereby transforming theoretical constructs into practical solutions. The narrative reinforces that precise, data-driven applications of resonance can lead to heightened performance, improved system coherence, and innovative technological breakthroughs. As this detailed exploration concludes, it calls for an ongoing commitment to inquiry, one that embraces both the art and science of resonance to foster future advancements in diverse fields. The foundation laid by this analysis serves as a stepping stone for further research, ultimately ensuring that the transformative power of resonance will continue to inspire profound progress in scientific and practical endeavors. Commitment to this evolving discipline is both a professional mandate and a catalyst for lifelong innovation and discovery in every field.